Howdy and welcome back. So we'll go ahead and continue our discussion on overloaded operators with respect to user-defined types by just going through a brief discussion of calling an overloaded operator and kind of what that entails. I know I've already alluded to that in a good amount in the last video, but we'll go ahead and just reinforce it here. So calling an overloaded operator when it is a member. So we frequently are going to go ahead and use an overloaded operator indirectly using the operator on arguments of a suitable type. So, for addition, it might be writing something like something plus something else. We can also call an overloaded operator using the function call syntax that you're familiar with. Remember when we provided a definition for the overloaded operator in terms of our color class, remember here that we essentially defined it as a function with the name operator followed by the symbol for the operator that we'd like to go ahead and overload, followed by, as a non-member, the number, 2 parameters if it was a binary operator, 1 for a unary operator. Both of these calling mechanisms are equivalent. Both call the non-member function operator plus, passing something as the first argument. So something, I know in saying that might have been overlooked, and then something else as the second argument. So again, that's simply a mapping of the right-hand side is passed as the second argument. The left-hand side is passed as the first. Now let's go ahead and talk about calling an overloaded operator for that's declared as a member function. So again, we frequently use an overloaded operator indirectly using the operator on arguments of a suitable type. So here, something plus something else. That could be 2 color objects, whatever it might be. But let's assume it's a definition that we've gone ahead and provided. When we call an overloaded operator that's been declared as a member of our user-defined type, using function call syntax, we name an object to which to run the function. We use the dot operator to note the member function we are interested in calling, and we provide any necessary objects. So this would look like something is the object that's essentially that we're going to invoke the member function on. Operator is the name of the member function, and the argument here is going to be something else. Remember that the object that's invoking this, or the object for which this member function is being invoked, is going to be implicitly passed to that operator, to that member function. So we will have access to it within the definition, which is why we can do things such as C1.R255. Since C1 is passed implicitly to R, we know that we'd like to assign C1's R value at 259 and not say C2's. Same thing's going on here, which is the reason why we essentially have one less argument than we would anticipate had the operator been overloaded as a non-member helper function. So the next question is, well, when we're going ahead and defining our overloaded operators, should we go ahead and define them as members or non-member helper functions? And we'll get into that here shortly.